Okay, so I'm going to do these questions the exact same way as I did the other ones, except I may not always be able to use special triangles. My process when I'm determining angles is number one, can I use my special triangles to find the related angle? And if I can't use that, my second option would be to use the graph. So perhaps the value is 1, -1, or 0, and I can do a quick sketch of the graph and determine the angle from there. And if I can't do that, my third option to find the related angle is to use my calculator. So if I have been asked to find the values of theta if cosine theta is 1/4, I'm going to follow the same steps I did with the other questions. The first thing I'm going to do is determine which quadrant it's in by using my cast rule. So my cosine ratio is positive, so I know it's going to be in quadrant 1 or quadrant 4. So I'll draw my diagram. So previously, we would then determine the related angle using the special triangles. But 1/4 is not values that would appear on my special triangles, and also not values that I would be able to determine from my graph. So we are going to use our calculator using to find the related angle. So find the related angle using our calculator. And make sure it is in radian mode. So we can determine angles using pi radians, but we can also determine it using decimal radians. So if you think of pi as the same as 180, in decimal radians, it would be 3.14 radians. Right? So pi radians is the same as 3.14 radians. 2 pi radians would be the same as 6.28 radians. Okay? So if I'm finding my related angle using my calculator, I would do shift cosine of the ratio, 1/4. And that will allow me to determine the related angle in decimal radians, making sure my mode is in radians. I'll do shift cosine of 1/4. And it works out to be 1.32. So that is a 1.32 related angle in quadrant 1, or a 1.32 related angle in quadrant 4. So my solution, remember we determine our solution from 0 in the positive direction, so I'm going to end at the terminal arm or the hypotenuse. So in quadrant 1, it will just be 1.32. And then in quadrant 4, it'll be all the way around here. So quadrant 4 is going to be 2 pi, or 6.28 minus 1.32. And that will give me my second solution. So let's just calculate that. So in quadrant 4, it would be 4.96 radians. Okay, so sometimes your answer will be in decimal radians, or sometimes when we do equations where we have to factor, you might get some that are in pi radians and some that are in decimal radians. Okay, so sine theta equals -3/4. So same process, let's decide what quadrant it's in. So it's a negative sine ratio. So it's going to be in quadrant 3 or quadrant 4. I'm going to draw my diagram. And the sides are opposite over hypotenuse. Can't use my special triangles. That doesn't look like any of my special triangles. So I'm going to use my calculator to find the related angle. So the related angle will be the inverse of sine of 3/4. I am not going to include the negative. All I want to know is the related angle. If I include the negative, it's going to go to the closest answer, which would be quadrant 3. Okay, and then you'll have to figure out the related angle for that. So I'll just show you in a second. Okay, so I'm just going to do shift sine of 3/4. which is 0.85. So that means my related angle is 0.85. So this angle here is 0.85 decimal radians, and so is this angle. If I did shift sine of -3/4, so let's just see the difference. I get an answer of -0.84 or 85. Well, what does that mean? That means that the calculator, because I put a negative, the calculator has gone to the closest answer. And so it started at 0 and it's gone this way. So it's gone to the closest terminal arm in the fastest way possible. So it went in the negative direction to the closest terminal arm. So that's why it's probably not a great idea to include the negative, because you might not understand what you've found. If you leave out the negative and just do the 3/4, the cast rule takes care of the negative, right? By using the cast rule, I'm determining which quadrants it's negative in, so I don't need to worry about the negative sign when I do my related angle. Okay? So my solution will be from 0 to the terminal arm. So over here in quadrant 3, it's going to be pi plus 0.85. And then in quadrant 4, it's going to be 2 pi minus 0.85. So you can use pi or 3.14. It doesn't really matter which one you use. Your calculator is going to change it to 3.14 anyway. So pi plus 0.84 is 3.99. And then 2 pi minus 0.85 is 5.43. So that is my answer in decimal radians. Okay, any questions on that? So it's done exactly the same way, except the only thing that's different is that we are determining our related angle in a different way. No, oh, Kristen, you're ahead. Yeah, that's fine. You can leave and do the task because you are ahead of everybody else. Okay, some questions might give you your angle with a point. Okay, so there's some questions that say you have a point on the terminal arm of an angle in standard position. So standard position means going in the positive direction, so counterclockwise, without going around more than once. So just in one rotation. That's what standard position means. Determine the exact value of cosine theta. So I'm going to plot the point -3,5. So -3,5 would be over here, and that lies on the terminal arm. So I'm going to create a triangle by joining that point up to the x-axis. And so by giving me that point, I know that this side length is 3 and this hypotenuse, this vertical side is 5. Hypotenuse. Okay, so I know to get to that point, I had to go left 3 and up 5 to get to that point. So that gives me 2 sides of the triangle. I am asked to state the exact value of cosine theta. And I know that cosine is the adjacent side and the hypotenuse. Well, I don't have the hypotenuse, so I'm going to have to figure that out. Okay, so I know it's a right angle triangle. So I'm going to substitute in the 2 sides that are given to find the hypotenuse. And so C will be 34, or C squared. So C is going to be the square root of 34. It wants it as an exact value. Okay, so that means no decimals. So we are going to leave the hypotenuse as root 34. We are not going to change it to a decimal. So when I do my cosine ratio, the adjacent side is 3 and the hypotenuse is root 34. You do not have to rationalize that. You can if you want, but you don't have to rationalize. We may need to simplify it into a mixed radical, but for now we'll just leave it as root 34. It can't be simplified any further. We don't want to change it to a decimal because it's not proper math form to put a decimal inside a rational expression. That's just one of those things that we don't do. Okay? So you can just leave that as 3 over root 34. The second part of the question says determine the value of theta in decimal radians. Okay, so now I'm going to use my calculator. So if cosine theta is 3 over root 34, and I want to find theta, or the related angle, then I can just use my calculator to type that in. So I'm going to do the inverse cosine of 3 divided by root 34. And that gives me a decimal radian of 1.03. Now remember that it's in quadrant 2. So you have determined this related angle as 1.03. The actual value of theta is from 0 to that terminal arm. So theta would be pi minus the related angle. So that is 2.11 radians. Okay, so don't forget that the value of theta is from 0 to the terminal arm. You just found the related angle. Okay, so you still have to do that calculation. So we're not quite at pi. So we subtract the related angle from pi to find the measure from 0 to that terminal arm. Okay, all right. Once you've just done ratios, you will get some equations that you have to solve. Okay, so now we're getting into solving for x or solving for theta. And it will give you an interval over which to solve. Right, so it's going to say, it's asking you for the values of x between 0 and 2 pi. So going once around in the positive direction. So if you just have sine or cosine and you don't have any quadratics, no squares, all we have to do is isolate for cosine. Right, it's just like solving for x. If that was just an x, right, so if it was 2x plus 1 equals 0 and I wanted to solve for x, I would just isolate. Right, so that's all I'm doing. So I'm going to isolate for x by moving the 1 to the right side and then dividing by 2. Okay? And then this just becomes like the questions we did previously. We're going to use the cast rule to determine the quadrant. It's a negative cosine ratio, so cosine is negative in quadrant 2 and 3. So I'm going to draw my diagram. I'm going to label the sides that I have been given. So cosine is adjacent and hypotenuse. So I'm going to label that on my diagram. And then I'm going to decide, so my 3 options are, number 1, can I use my special triangle? Number 2, do I have to use the graph? Or number 3, do I need to use my calculator? Looking at this, this looks like one of my special triangles. So I can determine my related angle using my pi over 3 special triangle. So this angle here is pi over 3. So I just look at my special triangle and see if it matches up. So if that is pi over 3, now I can solve for x. So one answer would be pi minus pi over 3. And the second answer would be pi plus pi over 3. So quadrant 2, it would be 2 pi over 3. Quadrant 3, it would be 4 pi over 3. Okay, so the questions where you're solving, you just have to go that one extra step where you have to isolate for sine or cosine before you solve for theta. So here's another one. It just wants it over the interval 0 to 2 pi. So just going once around in the positive direction. I'm going to isolate for sine. So I'm going to move to 3. I'm going to divide by 4, and it's sine squared, so I need to square root to determine my ratio. And when you square root, you will always get a positive and negative solution. That is important. Okay, so whenever we square root a number, we could have a positive answer or a negative answer. I cannot square root 3, but I could square root 4. So sine theta ratio is positive root 3 over 2 or negative root 3 over 2. So according to my cast rule, it could be in all 4 quadrants. If it's positive root 3 over 2, it could be in quadrant 1 or 2. If it's negative root 3 over 2, it could be in quadrant 3 or 4. So my answer is going to be in all 4 quadrants in this question, for the main reason that I have a positive and a negative. So my related angle, sine is opposite over hypotenuse. So the opposite side is root 3. The hypotenuse is 2. So it has a related angle of pi over 3 again. And it's pi over 3 in all 4 quadrants. So in quadrant 1, it would be pi over 3. In quadrant 2, it would be 2 pi over 3. In quadrant 3, it would be 4 pi over 3. And in quadrant 4, it would be 5 pi over 3. Okay. So in quadrant 2, we're not quite at pi, so we're going to subtract the related angle from pi. In quadrant 3, we're past pi. So we're going to add the related angle to pi, and then in quadrant 4, we're not quite at 2 pi. So we're going to subtract pi over 3 from 2 pi. Okay, so that's all 4 quadrants for that solution. Okay, I'm going to stop right there before we get into the factoring questions. We'll do that on Wednesday. Tomorrow will be a work period. You can